Okay, just got done with these exceptions. Now we're going to slide into this next thing, which is really diving into those boxes and those arrows, orbital notation. So in IB, it can be called an orbital diagram, or it can be called box and arrow notation. Box and arrow notation is pretty common verbiage or terminology for IB. So that box and arrow notation. So basically, it's like instead of just doing the configuration, the 1s2, the 2s2, etc., you have to do a diagram or draw your orbitals and electrons out and show what they look like. So the Hund's rule, you don't need to memorize this. Basically, it's just when we fill the boxes, we put an electron in each box and spread them out. Remember, electrons don't like each other. They are negative. They are going to push each other away. So if they're in a space, a three-dimensional space, they're going to push each other in opposite directions. So it says write out the orbital diagrams or box and arrow notation. And so two words for the same thing. And so we're going to draw that out for sulfur, iron, and rubidium. So sulfur, iron, and rubidium. So I'm going to do this on a different page just so that I have space. One thing to recognize here is that these cannot be abbreviated. They are have to be written out fully. And so that's just sort of a bum deal on these. So here we go. Let's zoom in on the old periodic table and let's clean this up a bit. So let's get rid of that stuff there. We'll keep our scandium and we'll just work kind of at the top here and we'll work through these. You don't ever have to do a lot of these because they take a whole bunch of space. So first thing is we're going to be doing the sulfur. Looks like the sulfur, the iron, and the rubidium. So here we go. Let's go and find our sulfur on our periodic table. And there it is, number 16. So we're going to have to do 16 of these. So it works just the same as a configuration. So you're still thinking row, block, spaces. It's just you have to draw things out now. So we would do 1s, and we'd put a box here, and we put 2 electrons, one up, one down. Okay. Kind of sloppy looking. Maybe we'll clean that up. And so 1 up, 1 down. So let's try this again. 1s, and then there's my box like that. And then we're going to put in an electron, 1 going up, 1 going down. I use the half arrows. You can use full arrows. Just half arrows are quicker. So that's hydrogen, helium. Row 2, S block, 1, 2. So basically you need a box for the maximum amount of electrons. So S gets 1 box. So the S is going to get 1 box. And so the S is going to get 1 box because it's small. And then the P is going to get 3 boxes because it's bigger. The D is going to get 5 boxes. And then the F gets 7. Now you're not going to have to do the F, but you can write it down. Those are the ones that are going to come up. So these are just spaces that can hold electrons. So it's a 3-dimensional object. There's spaces that can hold the electrons, and that's what these are. And so we're going to go over here to 2p. So the P gets 3 boxes. So here's my 3 boxes, and here's 2p. And then we'll put, oops, I should talk about this. You really should put 1 in each box and then fill them up. So that's really the order because remember they spread out. So now we're on sodium. We got to go to sulfur. So we're down here. So that's going to be 3s. And then there we are, 3p. So I'm going to go 3 boxes. 1, 2, 3, 3p. And there's 4 spaces. So 1, 2, 3, and 4. And then you are done. Now, one of the things that you can see from this is it will show you unpaired electrons. So in this situation, we have 2 unpaired electrons. So unpaired electrons are important because those are places where something can bond. So sulfur can bond in this spot and in this spot because there's an electron there that can form a bond. And so a lot of times what they talk about is they talk about unpaired electrons in these questions. They ask you something about like, hey, unpaired electrons, how many do you have? And so if you look at the last part of your orbital diagram, that's going to be the place where you can figure out unpaired electrons. So this has 2 unpaired electrons. You might want to write that down in the notes. So now we're going to do iron. So I'm going to clean this up a little bit. And what I'm going to show you is that this doesn't really change. So I'm not going to erase all of this because it's just going to be the same thing. We're just going to go a little bit farther. And so let me clean a little bit of this up. And let's go ahead and identify where we're going. Iron. Okay, so we're going to keep going. Well, let's go ahead and so we did 1s, 2s, 2p, 3s. So we're here. So now we're going to go back and we're going to do our 3p again. But we're just going to fill it up. 1, 2, 3, 4, 5, 6. Okay, so that take us to argon. Then we're down here at 4s. So 4s. And then we're in the D block. So I've got to do 5 boxes. So I got to kind of watch my spacing here. So I did not give myself a bunch of space. Let's go 1, 2, 3, 4, 5. Now you always write out every box, even if you're not going to put anything in there. And so this is 3D. And so now we get, let's count. We got 1, 2, 3, 4, 5. We got 6 spaces. Okay. So we're going to go 1, 2, 3, 4, 5. See, I'm spread them out. They don't like each other. 1, 2, 3, 4, 5, and then 6 right there. So this would have how many unpaired electrons? It would have 4 unpaired electrons. 1, 2, 3, 4 spaces where you could put an additional bond. So maybe do a little bit better color. So it'd be here's unpaired, here's unpaired, here's unpaired, and here's unpaired. So there you go, 4 unpaired electrons. That's a common question. So, okay, why don't you guys try the rubidium, which is right here. See if you guys can do that one. It's a long one, right? So it could take a bit of time, but give that one a whirl and then see how you do, and then I'll do that in a minute. Okay, I'll clean this up. Giving you guys a bit of time to fix that. So here we go. Okay, so cleaned all that up. Here we go. We're going to go down to that rubidium. Should have enough time while I clean that up to get that sorted out. So let me fix this. So there's my 4s2. So this would take me 1s2. So that takes me here and here. And then 2s2, 2p6, 3s2, 3p6. So we're down here at the D. So I'm going to have to fill this one entirely up. So I got to put my D block back. So there's my 5 for that. Boom, boom, boom. So it'd be like this. Now you're going to use all of it because you're going to go past iron because we're going to rubidium. So that would take care of all of those. Now I got to do this. So I'm kind of running out of space. I'm going to drop it right down here. So this is going to be back to row 4. This is a P block. So 1, 2, 3. So that'd be 4P. And I'm going to use them all. And then right here, there's rubidium. So it's 1 box for the S's, 5. Oops, that's not a 5. 5S. And then 1 arrow because I don't want to go to strontium. I just want to land on rubidium. So there it is. And that has 1 unpaired. So it has 1 unpaired electron. And it's right there. So, all right, so that gives you kind of idea of the orbital diagrams. And so we'll Make sure you get those down. Okay. So I kind of cleaned everything up. You guys should have filled out all of this with the stuff we just covered. So for whatever reason you didn't write it down, you want to get it down. So we did the orbital diagram. So we completed the sulfur, the iron, and the rubidium. Okay, so now what we're looking at here is this bit here, this example 13, and this is the other exception. Okay, so this is the other exception, and this is the other thing you have to memorize. So you got to memorize the weird exceptions that are just different than normal, and then you also have to memorize how ions are created. And so what happens is that ions are created in a slightly different manner